In 2017, a team at Google published a paper called Attention is All You Need. It introduced the transformer, and it changed everything. This single architecture is behind ChatGPT, Claude, Google Translate, and almost every major AI breakthrough since. Let's understand why. Remember the encoder-decoder bottleneck? One tiny summary vector had to capture the meaning of an entire sentence. Attention solves this beautifully. Instead of compressing everything into one vector, Attention lets the decoder look back at every single word in the input and decide which words are most relevant right now. Think of it like highlighting a textbook. When you're answering a question, you don't reread the whole chapter. You scan for the most relevant highlighted passages. For example, when translating a French sentence to English, and the decoder is generating the word black, the attention mechanism highlights the French word noir, because that's the most relevant word for this particular output. Self-attention takes this further. Instead of just looking at the input from the decoder, every word in a sentence looks at every other word in the same sentence. In the sentence "the cat sat on the mat because it was tired," self-attention helps the model figure out that it refers to the cat, not the mat. Each word builds a richer understanding by considering its relationship to all other words. The transformer takes self-attention and builds a complete architecture around it. Here's the key idea: instead of processing words one at a time like an RNN, the transformer processes all words in parallel, all at once. Think about the difference between reading a book one word at a time versus seeing the entire page at once. The transformer sees the whole page. It uses something called multi-head attention. Instead of paying attention in one way, it pays attention in multiple ways simultaneously. One head might focus on grammar, another on meaning, another on position. It's like having multiple experts each analyzing the sentence from a different angle. Since words come in an order but the transformer sees them all at once, it needs a way to know which word comes first, second, third. That's what positional encoding does. It adds a unique signal to each word based on its position in the sentence. There are two flavors of transformers. Encoder-only models like BERT are great at understanding text. Decoder-only models like GPT and Claude are great at generating text. The original transformer used both an encoder and a decoder together. The transformer was a revolution. By processing words in parallel, it could be trained on massive amounts of data using powerful GPUs. By using attention instead of recurrence, it could handle very long sequences without forgetting. And it scaled beautifully. Make it bigger, give it more data, and it just keeps getting smarter. This scalability is what led directly to the large language models that are changing the world today. That's our final video.